Hey scholars, welcome to 14.4. How long will supplies last of non-renewable mineral resources? That's kind of the question we're all asking, since we're all still using non-renewable resources as our main method of energy. And a lot of the things that really what's happening with the world, and it's causing a lot of conflict, at least right now, and it will continue to do so as long as we use non-renewable resources, is the fact that it's really they're distributed unevenly. There's about 5 different countries that have a majority of the non-renewable resources, and we're one of those, thankfully. The U.S., Canada, Russia, South Africa, and Australia. And I'm not talking about oil. Obviously, Iraq and Afghanistan, all those places in the Middle East have lots of oil. But as a whole, as far as mineral resources, the U.S., Canada, Russia, and South Africa, and Australia, have a bulk of those. So, will there be conflict upcoming for those resources? Possibly. Another one is that there's some things called strategic metal resources, which these are really not as much found in the United States. There are some that are found here, but they're also found elsewhere. And these are resources that there's no substitute for those. There's no substitute like, I'm going to use, let's say for energy for purposes. Well, I can use coal, but I can also burn wood and still do work with that. These resources are ones that are irreplaceable. There's no substitute for them. For instance, manganese, cobalt, chromium, platinum. And the scary thing about it is that all those different chemicals are found in traces in different electronics, which is kind of scary. Even platinum, which everyone thinks is big bling, very, very expensive metal, but it's also in your catalytic converter of your cars. That helps you basically, filter out the air a little bit better. It's in lots of different electronics as well. So those are kind of ones those are unevenly distributed as well, and there's no substitute for. So could those be fought over as well? Definitely a possibility. You guys take a look at this nanotechnology revolution. Nanotechnology is basically taking tiny particles that are 100,000th the width of a human hair, so super, super tiny, and storing information literally at the atom level inside of those. And there's lots of positive outlook for this. There's lots of things we could do with this if explored further, but there are some potential risks because we have known that nanoparticles can move across fetuses. Literally, the placenta can move across the membrane of the placenta. That's kind of scary. So if we make things very, very small all the time, those infiltrating our bodies are going to have long-lasting deadly effects. At least that's what the studies have shown. So we haven't really developed any guidelines for these or really don't know much about them and the negative effects. So kind of a cool thought of how much we could do with them, but also a scary thought at the same time. Supplies of non-renewable mineral resources can also be economically depleted. So obviously we've used oil for I don't know how long, and I don't know about you, but I'm definitely sick of paying for as much as I do for gas, and it's only going to get worse. I was reading the other day that over in Great Britain it's like $6 to $7 a gallon, if not even higher. So that's kind of crazy to think about, it being that high here. That kind of scares me. But there comes a point in time where the people can literally no longer purchase that resource to do what they need to do. And the people will decide to do something else. I mean, they're going to figure out a different resource. They're either going to walk or they're going to do without. They're going to figure out how to recycle or reuse that existing supply of whatever that resource is. They'll learn to waste less. They'll carpool. I'm just using gasoline as an example. They'll use less. They'll find a substitute. Maybe people have been using ethanol, E85 for their fuels, or they'll just do without. They'll figure out. Maybe they'll move closer to work and walk. I don't know. But when it becomes economically depleted, people do, the public, the consumer does certain things to literally, do away or use less because they can't afford to. And this is just showing you the natural capital depletion for non-renewable resources and showing how, the depletion time of how we use different things. By mining and using and throw away, no new discoveries, raising prices, that depletion time of that resource is going to be huge. It's going to be real quick. As we recycle, reuse, reduce consumption, we can draw out that resource for a long period of time. Unfortunately, I think we've used gasoline to the point where, we've used it as something easy for a very long time, which is we had a lot of it, but it's taking its toll on the environment, global warming, and also through all the problems that we see with pollution-wise. And now it's obviously becoming a scarce resource. So kind of a scary thought, but that just shows you depletion curves looking for non-renewable resources. Market prices affect supplies of non-renewable resources. So these things called subsidies, that word right here, basically means that the government gives you money to continue to do what you're doing because it's helping the economy. And that's what's happening with mining companies. They're literally keeping their prices low because they're getting money from the government in return for doing the job that they're doing. So their company is still profiting. So that keeps their prices of what they're mining artificially or relatively low. So that's kind of some things that have been happening for a long time. This is a case study, a good one to know. It is in the Barron's book, and it's also tested upon the U.S. General Mining Act law of 1872. And this encouraged mineral exploration and mining of hard rock minerals on U.S. public lands, public areas. And this helped develop and encourage the settlement to the west. People were going out there for gold in the early 1800s, late 1800s, moving out there for gold, and helped us move west because they were literally selling land for $5 an acre, which I know back then's a lot, but still until 1872, this all the way until 1995 could be bought for $5 an acre if you were to mine what the government wanted you to mine. And now what's happening is those companies are no longer is happening since the end of 95, and now those companies are now must pay for cleanup because they mine so much, they destroy the land. Now the government's trying to step in and make them do some cleaning up of that area. Is mining lower grade ores the answer? So if we run out of our high grade ores, which we're tending to do in the gas industry, are we going to mine lower grade ores? Should we go for the lower grade stuff? Well, if you do that, you're going to have to increase your cost of mining and processing larger volumes of ore. You need lots of fresh water in order to separate those things. Helps with the smelting process. The environmental impact when searching for all these little things is going to be huge. You have to improve your technology. Maybe use microorganisms to help break down things and get to the ore. It's going to be a slow process. What about genetic engineering of the microbes? Possibly, but I don't know if mining lower grade ore is the answer. I think really what we should switch to is renewable resources is my mind. Can we extend the supplies by getting minerals from the ocean? Well, we have lots of minerals in the ocean. They're suspended in water, which are hard to get things out of. There's lots of issues with that. They're dissolved in the low concentrations within the water. There's also some deposits along the bottom near the shorelines and the shelf. I mean, do we want to tamper with that anymore? I guess it's an option, but again, not one that I'd like to explore. There are some hydrothermal ore deposits literally around volcanic vents where that ore has been established. Manganese nodules like that. But if we mined around those, would that have an impact on aquatic life or any long-lasting environmental impact? Probably. It's just hard to say. Well, that brings us to the end of Chapter 14.4.